In this section, we are going to see the power MOSFET, their switching characteristics. First, what is MOSFET? MOSFET name is derived from the structure and the working. M stands for metal, that is source region, drain region and gate region of the MOSFET is made up of metal, usually sort of aluminium. Then oxide, second layer is made up of a SiO2 layer, so it is termed as oxide. Third layer, semiconductor, that is full, this region is made up of P and N type of semiconductor materials. So this is from the construction, metal, oxide, semiconductor. Now again field effect transistor, that is from the operation. Then when the MOSFET is working, here will be getting a electric field. Electric field when it's working. The electric field getting modified for the drain current flow from drain to source. That's its termed as a metal oxide semiconductor field effect transistor. For example, consider N-channel depletion MOSFET. N-channel depletion MOSFET. Usually is around two types: E MOSFET and D MOSFET. E MOSFET and D MOSFET. D MOSFET. E MOSFET means enhancement MOSFET. D MOSFET is depletion MOSFET. Enhancement in the sense that it is MOSFET is working, only you can increase the drain current. If you go for a D MOSFET, that is depletion MOSFET, you can increase the drain current as well as you can decrease the drain current. This is because of the structure. If we go for the D MOSFET, there will be a permanent channel. There will be a permanent channel between the source and drain. When it is working, that channel width is getting modified. According to that, there will be increase in drain current as well as decrease in drain current is achieved. If you go for an enhancement MOSFET, there is no permanent channel between the drain and source. Once we give the gate supply, then only there will be a generation of the channel between the drain and the source terminals. So depending upon this only, it is classified as a D MOSFET and E MOSFET. Now we are going to concentrate on the switching characteristics of MOSFET. That's why we consider as a D MOSFET, depletion MOSFET. This is the symbol of the D MOSFET. Again, D MOSFET and E MOSFET further classified into N channel as well as P channel, depending upon the conducting channel between the source and the drain. If it is a N channel, the source arrow towards the source, towards gate terminal, that represents the N channel MOSFET, and if it is arrowed away from this, it represents the P channel MOSFET. This is depletion MOSFET symbol and structure. Now we will move to the switching characteristics of the power MOSFET. Switching characteristics. Actually, when your switch is turned on, in the case of semiconductors, immediately won't be getting turned on and off because of the internal capacitances. Between the terminals. This otherwise called as the parasitic capacitance. We know that the terminals are gate, drain and source. These are the terminals of the MOSFET. Between gate and source there is a capacitance, parasitic capacitance, internal capacitance CGS, and similarly between gate and drain there is a capacitance CGD. Gate, drain, capacitance. Similarly, between drain and source, there is a capacitance CDS. And due to this capacitance effect, junction capacitance effect, there will be a delay during on time as well as off time. On time as well as off time. On time intervals are T, D, on. This is delay time. This is delay time during on. Then TR represent rise time during on. Similarly, off time intervals of MOSFET are off time intervals are one is T D off, that is again delay time during off, delay time Once